Okay, there is an aquarium behind me. It's a ecosystem. I'm going to read to you what we got so far. This is going to be published at exploratoryminds.net, and what I've got together at the moment is a bit rough. And so a friend Jerry is going to go through this and grammar correct, spell check, a few things here and there. An aquarium, if you're going to keep fish, needs to be an ecosystem. If you're going to keep shrimp, it needs to be an ecosystem. But what do I mean by ecosystem? Well, I mean all of its biological systems that you have in an aquarium, even the ones you can't see, the bacteria, need to be in on healthy terms and agreement with other things in a healthy balance. If you end up thinking, or if you've ever done the approach to keeping pets like fish or maybe shrimp or whatever, anything aquatic pets, then if your approach is like stick your gravel in, stick your water in, and some artificial ornaments, then the water is going to fail very quickly, and you're going to have a lot of trouble with it clouding a lot. Um, and then if you do water changes, that's more stress for the fish as well, because suddenly there's going to be water chemistry change because there's water change, and you think you're looking after your fish by doing the water change and make it clean again, but there's nothing to break down their waste. They essentially are in a container swimming around within their own toilet. We as human beings, we flush, right? We flush waste out. So there needs to be a cycle, and a it's a nitrogen cycle going on. In the tank behind me, the water is crystal clear. We'll get some footage at some point. I don't know if you can just see the light shining. From that behind me. Some people are seeing what's in there. So it's like plants and shrimp, neocardinia shrimp. They're doing really well, by the way. And I think it looked like there was a bit of an orgy going on yesterday morning. So we're going to have baby shrimp at some point. They're growing up and they appear to be very active. They're fascinating to watch. They have their active spur for so many hours per day, and then they're all settled down and be chilling out for a while, for quite some time. And they seem to have their routine. It's fascinating to watch. So, nitrogen cycle. Um, Nitrogen, it makes up about 78% of our atmosphere on Earth. So this is 78% of inert version of this. The majority of organisms can't use this, as we've got here actually talking about this article in front of me that we're putting together, who needs some corrections here and there. The cycle begins with nitrogen fixation, where atmospheric nitrogen is converted into usable forms like ammonia, NH3, otherwise nitrogen in inert form is N2. This can happen through many natural processes. Even a lightning strike can provide the energy to break the strong N2 bonds, or through biological processes involving symbiotic bacteria like rhizobium and legume root nodules. They say rhizobium. If you've got a rhizome plant in your aquarium, or go and look up rhizomes, and you'll learn about the root system on those things and why they're useful in a fish tank or a shrimp enclosure, whatever you're keeping, any aquatic species that you want to keep and enclose. Primarily, my focus is on tropical freshwater, although some people would going for marine. Whatever you're going for, then all of this still applies in the terms of a cycle that needs to be going on to break down waste. Um, so, root nodules and free living bacteria like azo azotobacteria, azotobacter, sorry. Plus, human intervention can do this with industrial processes, such as the Haber-Bosch method. Also, fix nitrogen on a large scale to produce ammonia for fertilizers. I'm going to take that off. There's a few bits I need to edit for this article. Get rid of that line. Okay. Cut. So once fixed, ammonia is converted into nitrites, otherwise NO2 hyphen or minus NO2, and then nitrates NO3 hyphen. Through nitrification, a two-step process carried out by soil bacteria like Nitrosomonas and Nitrobacter. This is why in the aquarium behind me there is literally a dirt layer. It's aqua soil, which I bought specifically. You can use aquatic compost, which is like your regular compost for your garden, but it's been leveled down. It's been denutrified a little bit. It's not so high in its fertilization, but you need to cap it, otherwise all that nutrition is going to float about in your water, and things like bacterial growths that are biofilms and algal growths and other things are just going to have a field day because there's so much nutrition all at once. It's going to take over, and then if you had plants in there, they're screwed because the water's going to be cloudy and foul and they won't get the light for photosynthesis. Algal growth will coat the leaves and it just isn't going to happen in a balanced manner. So how do you stop that happening? You stop that by happening by capping that nutrition layer with sand. What I've got is they call it like like layering or lasagna. The lasagna is layered. So we have the nutrition-rich aqua soil. Then there's a layer of sort of coarse sand that I put in. Then there's a layer of very fine sand, and the whole at the bottom is about this thick in substrate at the bottom of the aquarium. And there's plants rooted into that. Without the capping layer, it's all going to go wrong. So you keep the nutrients in there underneath that, and a plant's roots will find it and utilize it and help purify your water and the whole waste cycle going on. So these nitrates are absorbed by plants through their root systems and used to build proteins and other essential compounds. This process is called assimilation, where the nitrogen enters the food web as plants are consumed by herbivores and then carnivores. Of course, you might think of that as a large herbivore eating the plant and then a larger animal eating that like something out like lions after zebras. However, in the aquarium, you can get there's all different types of crustaceans that are tiny, but that will feed on things in the water. The filter feeders, bacteria growths that might feed on that, and algal growths that are suspended in the water column. They feed on that. Daphnia, or otherwise known as a water flea, can feed on that, and fish can feed on those. So that's where you got a bit of a food chain where one thing is feeding on plant matter, and that thing that's feeding on plant matter can be eaten by something more like an animal that is eating that. So that's a bit of a cycle there. So when plants and animals die, decomposers such as bacteria and fungi break down organic matter in a process called ammonification. This is the rotting down or breaking down produces ammonia. This releasing ammonia back into the soil. Um, whereas I'm gonna need to correct that a little bit. There we go. In oxygen poor environments, denitrification occurs, where denitrifying bacteria like Clostridium and Pseudomonas, I'm not sure of it, Pseudomonas, I think I'm pronouncing it right, I'm not sure, convert nitrates back into nitrogen gas, N2, which returns to the atmosphere, completing the cycle. The biodiversity in your aquarium is crucial for things to be maintained. You need the nutrition for the plants, and you might get algal growth and biofilms feed on. If you put in driftwood, you're going to get bacteria that feed on the sugars in the driftwood, and these different bacteria have an agreement of where they're going to be and actually layered. But what we see is the unaided, the bacteria on its own, we can't see it, but they create these thick layers that does aid something we can see. It's called a biofilm. It's like a slimy layer. Don't worry about that. It's not going to foul your water, and it's going to be food. Well, shrimp loves to feed on it, but one layer of the bacteria is feeding on those sugars, and it will have a waste product after it's been feeding. So another layer of bacteria will feed on that, and they create this symbiotic relationship between each other, and you get this biofilm. Biofilms can also be eaten by snails, even fish might peck at it. Algal growths can be fed with the waste and nitrogen cycle, although you don't want too much algal growth fouling the or clouding the water, because photosynthesis for things that are more robust, like leafy ferns or leafy plants, if their leaves get coated with the algae, it's not going to utilize the photosynthesis or light coming through the water to grow and outcompete the algae, which is now taking over and creating an imbalance. The more waste you got and more nutrition, the waste and nutrition basically the same thing. It's nutrition for that which can utilize it, but it's waste as far as a occupant like a fish or shrimp is concerned. That every creature on every level will produce waste, right? One biological system's waste is another biological system's sustenance. I know it sounds disgusting, but that is what happens. And the problem with that is your biodiversity will be ruined, and your fish will die, and other things will die if you have too much nutrition all at once. It's not like look, all this nutrition, all this variety, everything's going to do well. It's quite the opposite, because it's too much all at once, and you're going to get a narrowing down. There won't be fish to feed on anything, because the water is going to be clouded and foul. The oxygenation of water is going to struggle. The gases exchange in the water is going to be struggling, because algal growths and scum and biofilms will be capping the surface of the water. Now you got a problem with things that the surface tension of the water is not broken, allowing toxic gases to escape. So many things will die, even things that are different types of bacteria that aid this cycle. So keep in mind, go and research the nitrogen cycle if you are getting into keeping aquatic occupants. Please don't go and shove a load of gravel in there and put some artificial ornaments in there and prop your fish in and expect it to do well. It won't. and you're going to be struggling with water changes because it's going to be cloudy here and there. You're going to be struggling with algal growths. You're going to struggle with the fish won't be doing too well. There's um, issues with the scales. The fish won't be healthy. Um, all kinds of issues, even if you put a filter unit in there. The best thing about what's going on in a filter, a mechanical filter, would be all that biology going on and all that cycle going on in the filter sponge in there. This is also why you're told if you're going to clean out your filter, only clean half of it and keep some of it going because it's helping break down the waste because there's bacteria in there helping it breaking it down. This whole cycle happens straight from inert nitrogen, then can become ammonia once it's split, and then things can feed on the ammonia, and then that produces things like nitrates. The plants then feed on. Plants do well, and it keeps these levels down where other things can do well. That can peck at algae that might be doing moderately well, but not taking over things, and biofilms, bacterial growths here and there, fungal growths that these things can feed on, and filter feeders like water fleas can do well for a while, and a fish can come along and eat this tiny packet. There's a water flea, and it's very nutritional for the fish. Whole cycle keeps going round and around. There's somebody on YouTube who's got like a 4 foot fish tank. I think it's about 4 foot. He goes on. He's called Father Fish, right? And calls himself Father Fish. I think he's in Florida. And he teaches and talks about this whole cycle as well as other things. He he kind of makes a point of that you don't need to pay attention to nitrogen cycle if you just got a tank that you got your dirt substrate and you cap it and you put Perfora plants in. It's all going to take care of itself. Anyway, it's a good point, but also a more important point from a personal perspective is understanding why that works as opposed to shoving gravel in there and then a bunch of fish in there in the water, right? Your water is always going to suffer. It's always going to be foul. But he's done this fish tank, and it was like for 20 years or maybe more. So it's a long, long time. No water changes at all. All he's done is top it up because evaporation happens. If you put a air stone in, which there is in the tank behind me, you're going to create agitation on the surface tension to allow toxic gases to escape, by the way. And the air stone is not oxygenating the water until those bubbles hit the surface of the water and break the surface tension. It's not about those tiny bubbles dissolving into the water to start with. It's about breaking the surface tension so there's an exchange once that in that microsecond there is a break on the surface tension where the bubbles pop at the top. So people thinking like they're going to tune their air stone to make it like the bubbles really, really fine, then it's going to be really, really well oxygenated water and doesn't do anything. Breaking the water surface tension is the important bit there. Yeah, I think that's all we got to say on that. It's been a long time since I put out an Exploratory Minds video. This is another one to put out and to pinpoint. This is one of the things I'm writing about in the biology of your fish tank equals the biology of how the world works out there. There's also things that are breaking down the ammonia. That science, by the way, still to this day, they don't know what it is. The bacteria is breaking it down, and there's other processes breaking it down, but it's something else that is trying to break this down. And I think they called it archaea or archaea, and they don't know how to categorize it. They don't know if it's what it is, a bacteria, a or something else, but it's playing an important part, and it's also playing a much vaster and huger, larger degree out there, out in the world. Without it, the whole food chain would probably collapse. Thank you very much. Take care. I'll look forward to doing another video. Perhaps we could look into Archaea a bit and make a video on that if they've got any new information on that. Cheers. This has been Exploratory Minds. I am Jack, and if you want to check out exploratoryminds.net, at the moment it's not much to look at, but we will get there. Thank you very much for watching. Take care. Bye.